Hello, I'm Arseny Tarasov, board member of Energy Alliance at EU Tech Chamber and CEO of HiPer. And today we will speak about a very hot topic, how big data technologies increase energy efficiency. So first, let's look at the market trends. And energy optimization initiatives across different industries are primarily driven by two factors. First, high energy prices, and second, regulations. For example, in Europe, over 49,000 companies will have to report on their sustainability metrics and initiatives, and companies across the whole world must achieve Green Deal targets. So here you can see on the slide typical metrics, such as reaching net zero status, reducing CO2 emissions, and energy costs. While some of these targets can be achieved by renewables, they're still quite expensive. So we still need to invent a cheap source of green energy like fusion. And to reach both financial targets and sustainability targets, we're looking at energy efficiency initiatives as an alternative and a very affordable route. So another interesting trend that we see is that not only consumers of energy think about energy efficiency, but also oil and gas companies explore different options for themselves and their customers. An example would be Geoside, and it's an energy service company of Italgas Group. And recently, Geoside launched an open innovation challenge to find energy efficiency solutions to include in their own service portfolio. And we were very proud to become finalists of this challenge. So what are the challenges and opportunities in energy optimization? First of all, this challenge is quite new for the mass market. Some 5 years ago, majority of companies were not so concerned about energy optimization. And traditional approach to energy efficiency was a retrofit. However, retrofits are expensive and require significant capex with sometimes unpredictable ROI. So the new approach is to optimize operations. However, there are certain blockers on this route too. First of all, it's a lack of structured big data, because you can't optimize anything what you don't really measure. Second is companies lack professionals and easy to implement mass market tools in the area of energy efficiency. So what can be done? We believe that big data technologies and solutions provide an excellent opportunity to achieve energy efficiency with minimal investments, best ROI, and quick wins. That's really what we need, right? Especially at the executive level. And we're talking about less than 9 months ROI, and first results can be demonstrated in weeks, not months or years that we're used to. This approach requires non-invasive big data collection in existing facilities and without equipment downtime. The tools have to learn on technical operations data. Therefore, it's critically important. And unlike standard recommendations from old school energy consultants, big data tools provide advanced and personalized analytics and insights. AI tools can identify anomalies and inefficiencies, diagnose its cause, and provide tailored recommendations for improvements. So in order to achieve the benefits from big data and AI technologies, we really have to transform our approach to big data. So for example, if you want an athlete to achieve highest performance, just measuring blood pressure and heart rate once a day would not be sufficient, right? The same is relevant for energy efficiency. We really have to understand ongoing processes in real time. Therefore, data collection should be affordable and independent from equipment vendor. Legacy systems and equipment provide only a limited number of data points because traditionally it was just too expensive. And now we need to measure every single process and measure it not once per month or once per day, but continuously, like we measure heart with electrocardiogram. In this case, the collected big data can be efficiently used by AI tools. So once we have the big data, another transformation is in the way of analyzing it. Because majority of existing energy management systems provide what's called rules-based analysis and notifications. So companies have to go through complex manual process of programming specific rules and thresholds. And normally notifications are generated when something bad already happened. AI tools can analyze patterns and compare them with the previous periods in a huge library of potential anomalies and inefficiencies. And these tools work automatically, they're quick and easy to implement, and they identify potential problems before they occur, not after. So on this slide, you can see examples of anomalies that can be identified by AI, but not by rules-based systems, because the processes just change the pattern, as you can see, staying within the configured threshold and boundaries. New technologies also provide digital twin capabilities, where big data is integrated with representation of the building or processes to simplify field service and navigation inside. And having a unified big data warehouse allows to analyze different systems and processes in one application in one screen. Normally, with all the systems, different vendors and different solutions provide different applications that have to be managed on different screens. So this is a big advantage. I also wanted to give you an example of architecture of a PropTech big data platform. We built our platform based on our experience and industry requirements. So it contains required equipment for non-invasively collecting big data of technical operations, including, by the way, optical reading from old analog meters, then integration with third-party systems and equipment, and high-load software to process and analyze streams of big data and storing it for many, many years. Because the value of such data is really many years of operation. We, for example, have a library of 4 years of operation of different objects across different industries. Also, in addition to the technology, we have developed a 6-phase energy optimization project methodology, which can deliver from 15 to 70% of CO2 emission reduction. So first, we build and analyze what's called a business energy model, or BEM. And depending on as-is situation, which is identified during stage 2, one of 3 routes is proposed. It's optimization, retrofit, or demolition. Right? Obviously, retrofit and rebuild require major investments. And at the same time, significant results are achieved with just optimization of operations. And based on our experience, almost every business can reduce at least 10 or 15% of its energy consumption. And big data tools help to identify inefficiencies, create an action plan, and sustain efficient operations after implementation. So I wanted to give you several examples of how big data systems help to build a business energy model, optimize it, and achieve results. So first one is, as always, right, the example before and after. So this is an example of business energy model where we see generation, distribution, use, and losses of energy. As you can see, a lot of heat energy was lost at these manufacturing facilities, and that led to significant fossil fuels consumption. Through the analysis of the business energy model, it was proposed to recycle a big part of the wasted energy and then reuse it. So here on this business energy model, you can see a different approach to energy consumption, which helps to reduce almost 60% of fossil fuel consumption. Let me show you 2 more case studies to show where big data helps to identify inefficiencies and bring some very interesting results. So first one is the case study of a refrigeration warehouse with incorrect operation of the chilling system. So the customer was complaining that in this refrigeration warehouse, which maintained minus 18 degrees Celsius temperature, one of the compressors always required more attention. So it required more energy, more repair, and more maintenance. And they couldn't understand the reason why. With the existing system that only showed basic numbers and basic parameters, they could identify the cause of the problem. So when we collected the big data and analyzed the patterns of operation, not just single parameters, we identified that one of those compressors was behaving strangely. It was turning on and off several times per minute, and that caused tremendous issues with energy consumption, with maintenance and repairs. So by identifying this issue, this anomaly, and fixing it through reprogramming of the automatics, we managed to achieve up to 12% reduction in energy consumption, as well as reducing cost on maintenance and repairs. This is one example. The other example comes from another manufacturing facilities where analysis of big data and collection of big data from existing facility identified simultaneous cooling and heating in one of the workshops. And it led to 60 megawatts per hour every month in excessive consumption. Tremendous waste, and therefore implementing the solution was quick win, and ROI of the solution was less than 4 months. Right? Amazing result without actually doing any retrofits, rebuilds, or any significant capital investments. So here are just a few examples of how big data and big data analytics can help to reduce energy consumption, provide clear view and insights on what's happening on site, and make things much better. So let's summarize what we learned today. So first of all, there are significant drivers to save energy, achieve sustainability and Green Deal targets, and obviously massive energy efficiency initiatives will be required by companies across all industries, including oil and gas, including renewables, manufacturing, and others. At the same time, for majority of companies, this is a new challenge, right? And because of lack of experience, professionals, and tools, it's quite complicated. So people are looking for efficient and easy implement mass market tools to solve this problem. In order to start any optimization projects, we need a lot of big data to understand the as-is situation, right? And based on the big data of technical processes, we can identify one of the routes to move forward with energy optimization. It's either optimization of operations, retrofits, or demolition and rebuild. My recommendation would be to check if best results and best ROI can be achieved with optimization, because it's really low investment and low hanging fruit tools. And then if this will not be sufficient, companies can make a decision to go further with retrofits or rebuilds. The interesting thing is that the new big data companies and technologies demonstrate really great ROI and fastest time to results. This is quite new in the real estate and manufacturing industries, because normally companies are used to millions and millions of investments and years of projects, while big data tools can demonstrate results in weeks, maximum in months. So compared to legacy equipment and legacy approaches, this is a tremendous. So basically, this is what I wanted to quickly share with you today as a first start on the topic of big data for energy optimization. I would be really happy to connect with you on LinkedIn and discuss your experience and your projects in the area of energy initiatives and energy savings. Thank you very much. Let's meet and discuss this topic on LinkedIn. Bye.